A big hello to all of you. Today we are going to discuss the solid state chemistry, which we sometimes also refer as the materials chemistry. It basically deals with the structure, properties and types of various solids. First of all, let's see what are the basic properties that characterize a particular substance as a solid. Solids have fixed shape and volume. Please recall our discussion in states of matter, in which we discussed the comparative properties of solids, liquids and gases, the three states of matter. Liquids have fixed volume, but they do not have a fixed shape. They take the shape of the container. And the gases neither have fixed shape nor have fixed volume. Solids are also characterized by rigidity, incompressibility, slow diffusion and mechanical strength. Gases can be compressed to a great extent, whereas liquids can be compressed to some extent. Diffusion is fastest in case of gases. On the basis of the arrangement of the constituent particles, we can classify solids into two types. First is the crystalline solids and second is the amorphous solids. In crystalline solids, the constituent particles are arranged in a definite geometric pattern. Whether the particles are molecules or atoms or ions, they will always have a fixed pattern in which they can be arranged. Its examples are sodium chloride, potassium nitrate, lithium fluoride, copper sulfate, pentahydrate, and so many others. The second type of solids and the basis of arrangement are the amorphous solids. These solids are those in which the constituent particles do not have a particular order in their arrangement. For example, glass, rubber. I hope you remember we found glass as a very interesting substance because we also studied it as a supercooled liquid. Some of its properties belong to the category of amorphous solids, whereas some of its properties belong to that of liquids. To make the distinction between crystalline solids and amorphous solids more clear, let's discuss their properties one by one. The first property that we discussed for crystalline solids, that their constituent particles have a definite arrangement in three-dimensional space, due to which the crystalline solids have a definite geometrical shape. But the amorphous solids do not have any such definite geometrical shapes because there is no particular order of arrangement of their particles. The crystalline solids are characterized by sharp melting point, whereas amorphous solids do not have any sharp melting point. When the crystalline solids are cut with a sharp-edged tool, they split into pieces whose surfaces are very plain and smooth. Whereas in case of amorphous solids, when they are cut with a sharp-edged tool, the newly formed pieces do not have smooth surfaces. They can be irregular. The crystalline solids have a crystal symmetry which is not found in amorphous solids. Also, the crystalline solids possess anisotropic properties. That is, the magnitude of some of the physical properties of the crystalline solids, such as refractive index, coefficient of thermal expansion, or thermal and electrical conductivities, are different in different directions. Whereas amorphous solids possess isotropic properties. That is, the magnitude of their physical properties is same in all directions. The crystalline solids can be further classified on the basis of the constituent particles and the bonding that exists between those particles. So the crystalline solids are of four types: metallic solids, ionic solids, covalent solids, and molecular solids. The molecular solids are again classified into non-polar molecular solids, polar molecular solids, and hydrogen-bonded molecular solids. We'll discuss their properties one by one. The first type that we are going to discuss is the metallic solids. In metallic solids, the constituent particles are atoms which are packed together as closely as possible. It is considered that actually the solids have a lattice of their constituent particles in which the positive ions are embedded in a sea of electrons. According to one of the models which explains metallic lattice, the electrons of the metal atoms are free to move throughout the lattice. Therefore, it is considered that the positive ions are embedded in a sea of electrons. The metals are considered to be very good conductors of heat and electricity. They have moderate to high melting point. And examples of metallic solids are various metals such as copper, silver, gold, magnesium, aluminium, etc. The next type of crystalline solids are ionic solids, in which the constituent particles are positive and negatively charged ions, that is cations and anions. They are held together by strong electrostatic forces of attraction, which we also call Coulombic forces of attraction. Their crystal structure depends mainly upon the relative size of the cations and the anions. They are characterized by high melting points. They are insulators in the solid state, but they are considered to be pretty good conductors of heat and electricity in molten state and solution state. The examples of ionic solids are various ionic compounds such as sodium chloride, magnesium oxide, potassium chloride, barium chloride, and so on. The next type of solids are the covalent solids, in which the constituent particles are atoms. These atoms are held together by covalent bonds which are directional in nature. They show high melting points and they are insulators in nature. They do not conduct electricity. The common examples of covalent solids are diamond, silica, silicon carbide, etc. The fourth type are the molecular solids, in which the constituent particles are molecules, as the name itself suggests. These molecules are held together by weak forces such as van der Waals forces and hydrogen bonding. They show low melting points. They are insulators and poor thermal conductors. The examples of molecular solids are iodine, ice, dry ice, etc. Now let us see what are the various types of molecular solids. The first type are the non-polar molecular solids, in which the atoms are held together by weak dispersion forces or London forces. The second type are the polar molecular solids, in which molecules are held together by stronger forces, which are dipole-dipole interactions. And the third type of molecular solids are the hydrogen bonded solids, in which the molecules contain polar covalent bonds. We took the example of iodine, dry ice, and ice while discussing molecular solids. So we can say iodine molecules in carbon dioxide are non-polar, whereas in ice, the water molecules form hydrogen bonds with each other. Our next topic is the unit cell. A unit cell can be defined as the smallest unit of the crystal, which, when repeated again and again, gives the crystal of that particular substance. There are three types of unit cell based on their structure. The first type is the primitive or simple cube. Second is the body-centered cube, and third is the face-centered cube. Let us see how they are different from each other. This is a simple cube in which atoms are found at the corners of a cube. This is a body-centered cube. As you can see, the atoms are found at the corners of the cube and also in the center of the cube. And in face-centered cube, the atoms are found at all the corners of the cube along with the center of each face.